Welcome to G Fun Facts Online, where we dive into the most amazing and mind-boggling science happening right now. Today, we're shrinking things down, way down to the nanoscale, to explore a technology that's literally printing the future, Nano-3D printing of superconducting materials. Now, what are superconductors? Imagine materials that can conduct electricity with absolutely zero resistance, zero energy loss. Sounds like magic, right? And nano 3D printing? Think of it as an incredibly precise, microscopic 3D printer that can build complex, three-dimensional structures tinier than a human hair. When you combine these two, you unlock the door to a new era of quantum applications. This isn't just science fiction. It's happening now. Let's talk about some seriously cool, recent breakthroughs. Picture this. An international team, led by researchers at the Max Planck Institute, reported in May 2025 that they've created 3D superconducting nanostructures where they can actually control the superconducting state locally. That means they can effectively switch off superconductivity in specific, tiny parts of the material. This ability to have both superconducting and normal states coexisting is crucial for quantum mechanical effects, like creating weak links essential for ultrasensitive sensors. And get this, these nanostructures can even be turned on and off by simply rotating them in a magnetic field. We're talking reconfigurable superconducting devices. How amazing is that? But the innovation doesn't stop there. Researchers at Northwestern University and Fermi National Accelerator Laboratory have also made huge strides. They've developed a novel two-step process to 3D print a high-temperature superconductor called yttrium barium copper oxide, or YBCO for short. First, they print it in a less perfect form, and then, through a clever heat treatment process, they transform it into a single crystal. Why is that a big deal? Because single crystal structures have vastly superior electrical properties, like carrying significantly more current. This research, published in early 2025, shows we could soon be printing complex superconducting components like tiny, powerful toroidal coils. So, how exactly are scientists performing these microscopic miracles? Several cutting-edge techniques are in play. For instance, there's focused electron beam-induced deposition, or FEBID. This uses a focused electron beam to decompose precursor gases, depositing superconducting material onto a substrate with incredible precision, down to 10 to 30 nanometers. This allows them to create intricate 3D shapes, like nanowires and even tiny nanohelices. Then there's something truly mind-bending: DNA self-assembly. Yes, you heard that right. DNA. Scientists are using DNA strands, programmed to fold themselves into specific 3D shapes, like microscopic origami. This DNA scaffold is then coated with a superconducting material, like niobium, effectively creating a 3D inorganic superconducting nanostructure. They've even used this to make 3D arrays of Josephson junctions, which are key components for quantum tech. Another cool method is multi-photon lithography. Imagine being able to print tiny, perfectly formed lenses directly onto superconducting nanowire single-photon detectors. That's exactly what this technique does, massively boosting their ability to catch light and enhancing their detection efficiency. These detectors are vital for things like quantum optics and quantum communication. Now, why is all this tiny tech so important? The applications are nothing short of revolutionary, especially in the quantum realm. First up, quantum computing. Nano 3D printing allows for the precise engineering of superconducting circuits, including qubits, the fundamental building blocks of quantum computers. Being able to create 3D integrated qubits is a massive step towards scaling up quantum processors to tackle problems far beyond the reach of today's supercomputers. Next, quantum sensing. Think of skewids, or superconducting quantum interference devices. These are already the most sensitive magnetometers known to science. Nano 3D printing can make them even more powerful by packing more of their core components, Josephson junctions, into a smaller volume. We also just heard how 3D printed microlenses are supercharging single-photon detectors, crucial for advanced quantum communication. And it doesn't end there. These unique 3D nanostructured superconductors could lead to advanced electronics and spintronics. Curved 3D superconducting nano-architectures, like tiny niobium helices, show promise as super-sensitive detectors for microwave radiation. Plus, the ability to switch parts of a nanostructure's superconducting state, on or off, opens up possibilities for adaptive, multi-purpose components, complex superconducting logic, and even neuromorphic architectures that mimic the brain. Of course, like any frontier technology, there are challenges. Scientists are working hard to achieve ultra-high material purity, minimize defects during printing, and figure out how to scale these intricate processes for mass production. Characterizing these tiny, complex structures is also a tough nut to crack, but the progress is undeniable and incredibly exciting. The field is rapidly moving from flat, 2D films to intricate 3D architectures, unlocking new physics and a host of quantum applications. Future work will focus on refining these fabrication techniques, exploring new superconducting materials, and demonstrating even more complex and functional quantum devices. We might even see artificial intelligence and machine learning stepping in to help design and optimize these incredible nanostructures. So the next time you hear about 3D printing, remember it's not just for plastic toys anymore. It's building the very fabric of our quantum future, 1 nanometer at a time. What a fantastic fun fact! Thanks for tuning into G Fun Facts Online. Stay curious and join us next time for more mind-blowing insights into the world of science and technology.